Hi, I'm Drew Colthorp. I'm practice lead of software development in the Grand Rapids Office of Atomic Object. Today I'm going to talk a little bit about using artificial intelligence as developers and consultants. So things are moving really rapidly in this space. Things are changing all the time. There are new models, there are new tools, and because these tools are so complex, people are constantly learning new ways to use them or trick them to get the good results. So even though things are moving really quickly, though, there's some pretty important research that's already happening into the impact that these can have on people and their work and how effective they can help them be in that work. So today we're going to focus on a study from Harvard Business School. It's called Navigating the Jagged Technological Frontier. This study was focused specifically on consultancies, so it's near and dear to my heart at Atomic Object. So they put together a pretty huge study with a huge amount of effort, and they did so in partnership with BCG. BCG is a large management consulting company, one of the big three with McKinsey and Bain, and they have roughly 10,000 consultants. Together, BCG and Harvard Business School put together a study and designed a series of tasks for consultants to complete using GPT-4 as a tool to help them complete those tasks. And it was a pretty big lift. They wanted this to be really realistic work. They went so far as to put together a challenge and then check that with an executive at a shoe company to make sure that it was a realistic sort of task. And then about 800 people, or 7% of the BCG consultants participated in this. And much like us at Atomic, these are people that are highly skilled, highly engaged, very creative, and with a large variety of backgrounds and different levels of experience. So it was a really good study to provide a lot of data on how this can impact these sort of high human capital individuals. So what did they find? The results were pretty huge. They found that when things were going really well, people would get things done about 25% faster. And then that led to about 12% more things getting done overall. I kind of think of this as like there's switching costs and other things. So the tasks are getting done 25% faster, but that doesn't necessarily lead to 25% more tasks completed. And then with quality, we saw an even bigger jump. We saw an impact of 40% greater quality for people that were using large language models, GPT-4, in their work versus those that weren't. Now, these numbers are pretty huge, and they are something that are real and measured. They're not going to transfer perfectly to everybody's work as a developer, as a maker of some kind, of any kind of professional. But I mean, when we multiply these two things out, kind of combine them, like a 40% increase in quality and a 25% increase in speed, that's like an astounding 75% increase in like hypothetical value delivery. And that's a lot. That's a really big jump. And it's something that we can't really ignore. Even if that 75% doesn't play out in most cases, which we'll find out in a minute, it doesn't apply everywhere, that's still a big enough jump that people who care about doing their best work, about getting things done effectively and providing great value for their clients or for their employers, that can't be ignored. Right now, using AI is kind of a new thing. It's not really widespread. Not everybody is expecting it, but it's going to become more and more an expected part of the toolkit of any professional, and it's going to be really important to kind of adopt those in order to kind of keep up with what the expectations are in your industry. So let's talk a little bit more about the study. One of the things that I thought was a pretty compelling insight, but also just rang so true to me as somebody who uses large language models a lot, is that they're pretty uneven. One of the authors of the study put it this way: on some tasks, AI is immensely powerful, and on others, it fails completely or subtly. And unless you use AI a lot, you're not going to know which is which. And so this is something that I think anybody who's seen ridiculous DALL-E 3 images or tried to get GPT-4 to compose an email only to get it being just filled with repetitive junk, can see. It's great. It can be so powerful and so successful, but it just doesn't always kind of come together. They visualize it this way. You can kind of see here this sort of smooth curve visualizes a set of tasks that are all of equal difficulty for a human. And then this kind of wobbly curve kind of shows the capabilities of large language models. And you'll see that there are some things where it's what's a certain level of difficulty for a human might be easy and accomplished very well by a large language model. But then in other places, something that to a person doesn't seem meaningfully more difficult, it'll just fail horribly. And I think where things get the trickiest is where you're just outside the capabilities of the large language model. It seems like something it might be able to do. You get a result that on the surface looks great, but actually it's failing in subtle ways, and unless you're on your toes, you're not going to catch it. So let's start by talking a little bit about when we're within the frontier, within the capabilities of large language models and AI. Here's where we get those really compelling results I was quoting above. Here you can see a visualization. We've got the population in blue are the consultants that in the control group that didn't use AI at all. And then the green and the red curves show the consultants that used GPT-4 in their work. The green population just got given GPT-4 with no training, and the population in red had some training, so they were more comfortable with it and they knew how to use it more effectively. And you can see here the shift from blue as it moves to the right to where the green and the red curves are. That's that 40% lift in quality that we're talking about. It's pretty huge and pretty spectacular, and you get a little bit more of an uplift for the consultants that were comfortable with using large language models. But one of the things that's interesting about this curve is there's this period in the middle where the very top tier, the most effective consultants not using large language models, overlap with the bottom tier of consultants that are using large language models. And that's a pretty interesting space to look at, because that's showing us that the consultants who are the least skilled are now competing with the very best consultants that are not using large language models. This is kind of showing this way in which these tools can level the playing field, and it can lift up less skilled developers or other professionals in a way that it evens the playing field and increases the competition in the space. Somebody that's been used to being able to rely on their expertise and their skill as a differentiator, if you're not kind of following this wave and adopting these tools, you're going to find yourself with a lot more people able to compete with you than you had before. It's not just that the consultants using AI were more productive, more effective, had higher quality results. It's true that the consultants that were using this tool got pulled to the left and were producing higher quality output, but that effect didn't apply evenly throughout the population. Within the highest, top 50% of consultants by skill, there was only about a 17% uplift in their quality or their performance. And for the lower skilled consultants, there was a much more dramatic, 40+% uplift in their performance. In a way, the more skilled participants didn't need to maybe rely on AI as much to produce high quality results. But as a result, it didn't help them as much because it didn't increase their quality by as much as it increased the more junior consultants. And I think that this has a pretty big impact as well. It's not just that as AI gets adopted, lower skilled professionals are going to be competing with higher skilled professionals who are not using AI, but really everybody using AI, there's going to be this leveling of the playing field and this kind of increasing of competition, which is a great thing for people who are newer to their careers, newer to their professions. It can be something that can really help them develop more quickly and compete at a higher level. Maybe focusing on more interesting problems or more high-value ways of contributing. But all of that is about in these places where AI is at its best. And it's just as important to look at the places where AI struggles and doesn't do as well. They formulated the study and crafted a task specifically to explore this part of the space. They put together something where they asked the consultants to take a look at a combination of data that needed to be analyzed as well as user interviews. And they specifically set it up so that if this was just fed naively into GPT-4, it would come up with the wrong answer to kind of see what happened in those particular scenarios. Just as the results inside the frontier were very positive and uplifting for those that were using AI, this was like the opposite effect of that. The users of AI were more likely to come to the wrong conclusion. And it's kind of straightforward when you think about it. They had a machine saying, hey, here's what the outcome was, and then they trusted it too much. I think, right now especially, and this might change as models get better and smarter, but at least for the foreseeable future, we're kind of in a situation with large language models similar to where we're at with self-driving vehicles. They're good enough that you can let your guard down and you can become a little complacent and rely on them too heavily. But if you do so, they're not really good enough to provide you the reliability that you have to have in order for that to be a smart choice. So, just like with the self-driving cars, if you take your eyes off the wheel, if you're not paying attention and critically evaluating the work that you're getting from GPT-4 and really staying engaged and thinking critically and at a high level, there's a chance it's going to, run you in the wrong direction. So they took a close look at how this was done, because not everybody who used GPT-4 came to the wrong conclusion. It's true that those consultants were much more likely to come to the wrong conclusion, but that didn't apply to everybody. So they focused on those individuals that came to the right conclusion despite being led astray by the large language model. And then they try to kind of summarize what are the kinds of behaviors that they were seeing that led these consultants to have good outcomes. And they identified two sort of high-level strategies that I think provide useful metaphors for thinking about how you can incorporate AI and GPT-4 or other large language models into your workflow specifically. So the first is what they call the centaur strategy. So this comes from the mythological being, where that's, top half is human and the bottom half is horse. They kind of think about this or frame this strategy as being about sort of a strategic division of labor between large language models. You've got the human, kind of in the driver's seat overseeing things, but there's a clear separation between what tasks are done by the human and what tasks are done by the AI. The human knows and has an intuition for what the AI is likely to be successful at and delegates those tasks that are appropriate to the AI in order to get the really positive upsides that we see when we're in the jagged frontier, within the jagged frontier, but avoid the downsides that we see when we're operating outside of it. This requires developing that intuition, having familiarity with where it's strong and where it's not strong, and also thinking in a high-level, critical way about those results and how to make use of them. The other strategy that they identified was what they called the cyborg strategy. So whereas the centaur has this clean separation where top half human, bottom half horse, with the cyborg you have this much more fine-grained mixing kind of technology and human effort in a place where the boundaries become a little more blurry, or at least kind of articulate and finely detailed. With the cyborg strategy, this is one where it's not just whole tasks that are delegated to the AI by the human, but one where really even within a task, you might have little elements of it that are delegated to the AI for a much more ingrained, entwined workflow between what the human is doing and what the AI is doing. For me, at least, I think of this as being something where I analogize it to GitHub Copilot. So with Copilot, It's powered by the same large language model that you use in ChatGPT, but it's integrated into the programmer's text editor so that it can kind of always be active, always being participating, and it removes the barrier of what it takes to get the large language model to kind of know what it is that you're trying to do, what situation you're in, and what kind of results you're looking for. It can make suggestions as you type in a way where you can choose to accept the suggestions that work well, or reject those and just go ahead and do your own thing as the person that continues to be in the driver's seat. Another example they give in the paper in the study is, an example of starting to write a sentence and then asking the AI to continue it. It's a small, lower level detail for how you might use AI as part of your workflow, but it's also kind of a way that you can continue to get benefits to the quality and speed at which you're doing the work that you're doing, even in places where it's not as easy of a fit for a large language model.